Hello guys, welcome back to our Labs YouTube channel. In today's episode, we're going to be taking a look at how to write proper tests for your Cairo program. And testing is like pretty much very it's one of those skills you develop like from constant practice, right? But the whole goal of this particular episode is going to be like taking you through the very basics, walking you through like the syntaxes and all the like common things you need to know. But getting good at testing is going to require like a lot of practice. And without further ado, let's just get started. All right, so thus far we've made like pretty much very significant progress. It's been 11 episodes in, and we've learned quite a lot about the Cairo programming language. But when writing like programs, especially real world applications, like programs you're basically going to be using in like real life, right? People are really going to be using. You want to ensure you write tests for this program. So it's essentially when we talk about tests, we're talking about writing they're still basically Cairo codes that verify that the your program acts in like the expected manner, right? Like the behavior is because as a developer, of course, there's an intended behavior you have for like the programs you're writing, and thus with tests you only try to verify that that intended behavior you have is like essentially how like the program works. So we're going to be looking at the whole lot of things, right? We're going to be looking at things like the test attribute, the assert macro, these other different macros, right, which you can use within your test, the should panic attribute, and of course like the test module and the attributes you need to like append to them. And we're going to be looking at the anatomy of a test function, different types of tests, unit tests, integration tests, and so much on and so much more, right? So let's just hop into like VS Code and just get started with something. All right, now on back in our VS Code, I think the first thing we're just going to do is I'm going to come here and just, as always, do BAC 12, and we're going to call this, let's call this testing Cairo programs. Testing Cairo programs. All right, so I'm going to come here and I'm just going to create a new Scar project. I'm going to call this testing, and this time around we're going to use Starknet Foundry as our test runner, and that is going to do a bit more. Okay, we already have this created. All right, so I'm just going to come here and I'm going to rename this file. I'm going to call this BAC12. All right, so having done that, as you can see, we have like this new file which has been introduced, right? The snfoundry.toml. Now we're probably not going to be making much edits to this particular file, but I'll definitely want to like spotlight like the Starknet Foundry toolkit, which is like a very important tool for writing this, especially when you're building like smart contracts. Now hopping back, let's hop back into our browser and all right, so you come in here, you can find like the Starknet Foundry documentation. So right now, we're probably not going to be using it a lot until when we get into like when we start writing proper Starknet smart contracts. But Starknet Foundry is like a toolkit that provides you with like different things you need to like write to write full blown tests, right? For example, when you're testing smart contracts, there are a lot of like environmental variables which you would need to tinker around it. For example, the block timestamp, changing like the caller address, and so many more, right? Starknet Foundry enables you to do this. They also provide you with scripts you can actually use to like do a whole lot of things, deploy contracts, verify your contracts, interact with your contracts, and so many more. So we're going to be learning about Starknet Foundry when we get into the next section where we begin to talk about like writing Starknet smart contracts. But in the meanwhile, we're just going to stick to like basic Scarp Cairo testing. All right, so now back in our VS Code again, every other thing we know about the scarp.toml, you can see we have like the test command which now runs with snforge test. Okay, so we're going to just hop into BAC12 and into like lib.cairo. So in lib.cairo, you can see this this little smart contract which has been which comes with like the Starknet Foundry setup, right? So when the moment we try to like set up using Starknet Foundry, we got this boilerplate smart contract which we could actually play around with in our test, right? And then if you come into the test folder, you can see this text contract.cairo. Now this particular function is this particular folder, right, basically contains all what we call your integration test, right? So essentially the difference between your unit test and your integration test is your unit test most times is all going to be testing for like different components within like your contracts, for example, down to the smallest variable, the functions and every other thing, right? You're testing that these functions they behave like as intended. But when you talk about integration test, you're basically like testing how different like probably different components in your contract interact with each other, and probably like with external resources and stuff like that. So integration tests are like super important. But we're going to kick off like from unit test. So I'm going to go back into lib.cairo, and for now I'll clear all this, right? I'll just clear all this. And we can start with like a very basic function. So I'm going to write a function, a basic function that adds two numbers. And so it's going to take in X, maybe like a uint 16, and it's going to take in Y, which is also a uint 16, and probably return zeros like a uint 16. Okay, and sorry, and all we want to do, right, is we're just simply going to add the both numbers, X plus Y. Now this is a function. Like I said, it takes in two numbers and it returns like the addition of both numbers. Now, let's say we want to write a test to check that this function we just wrote like behaves as expected. What we need to do is we're going to create a different module called, like we're going to call this module test, right? But the first thing we need to do is we need to be able to tell the compiler, okay, this particular module, it consists of like just test functions, right? Or just test. And one of the reasons why I want to do this is it helps us limit like the number of things we have to like compile when we're compiling our smart contracts, right? And thus ensures that basically like the result of our compilations is a lot more lightweight. All right, so what I'm going to do is I'm going to come here. The way we do that, right, is we're going to use this attribute that says CFG, and we're going to say test. All right, so when we do this, right, we tell the compiler, okay, this particular module is a test module. There's really no need to like compile it except when we are actually like trying to run test, right? I want to test that the addition of two numbers like it happens. So the first thing we want to do, remember when we talked about like when we talked about modules and arranging your Cairo programs and stuff, right? We talked about how if like you're trying to refer to a function that exists within the same file, you could use something like the super keyword. So I'm just going to use the super keyword, and I'm going to like refer to add two numbers. Sorry. So I'm going to refer to like the add two numbers function. So we want to actually like use that. All right. Now I want to write my first test function. Now, like I said, tests are like you write tests the way you write like normal Cairo programs, right? But the way you differentiate, or the compiler differentiates between a normal function and a test function, right, is using the test attribute. So the test attribute is something like this, right? So when you do this, you tell the compiler that any function that comes below this, right, is going to be a test function. And the reason why this is important is because even within your test files, there are most times when you want to do some basic stuffs, right, like adding setups or trying to like do some stuff that are not necessarily like part of the test, but help like make the test work, right? You would probably not want to annotate the things you do not want the compiler to like run or something, right, with like the test attributes. So when you use like the test attribute, you're essentially telling the compiler, okay, I want this to actually be a test function. So I'm just going to say test add number. I'm just going to call this test add number function. And oftentimes, or most times, your test is really not going to like take in any arguments, right? So you do not really need any arguments for like your test function. Next thing we're going to do is we are going to now try to call the add two numbers. Now, when we call the add two numbers, we need to pass in two different numbers and it returns a value for us. So that value, we're going to store it in like in a variable called results, and we're going to call add two numbers, and I'm going to pass in 20 and pass in 10. All right. So we just called the add two numbers function. We passed in two variables and we're expecting a result of 30. Now the question is, how can we check that the result we get is actually like 30? So there are different ways we can do it. So we can do something like assert. So like I talked about all these different macros which the core library helps us with, right, or presents for us, right? We have the assert equals, which essentially helps check that two things are equal. We have the assert greater than equal to, which basically helps us check that maybe that one thing is greater than or equal to the other. We have greater than, which checks that a value is greater than the other. We have less than or equal to, we have the less than, and we have the not equal to. So these are different like assert statements you can basically like use within like a test. So I'm going to be using the assert equal to, and I want to check that the result is going to be, so we know that 20 plus 30 is going to be 30. So all we're doing essentially is we're saying we want to assert that the result is equal to 30. So in any case where the result is not equal to 30, we know that there's probably an issue with like our function. So to run, I'm just simply going to clear this and I'm going to run scarf test. Okay. We need to cd into BAC 12. I'm going to clear this. And I'm going to run again scarf test. So it's going to compile our contracts and then compile our test and try to run it. So we are getting an error here. So the error says, oh, right. So it is compiling our tests. I'm just going to delete this file for now. I'm going to delete this file because it has a lot of errors when I deleted the contract. So I'm just going to clear and I'm going to run that again. So as you can see, our test passed, right? And you can see we have it's annotated by this testing crate, and as you can see, this is like the function we're trying to test, the test add number function, and you can see the amount of gas we used like during the whole testing process. You can see how many tests passed, you can see details on how many tests failed, how many tests was skipped, how many tests was ignored, and so on and so forth, right? So the next one we're going to be looking at essentially is all the different macros, right? So we just talked about the assert equal. We also have I think the assert, so we're just going to use them in order. So the assert greater than equal to. So to make this work right, we could just simply do something like, okay, we want to assert that the result is maybe let's say it's greater than, this is greater than equal to, right? So even if you pass in 30 here, this should work. So 30, any value that is 30 or less than, it should work, right? Because we're just saying that we're checking that the result is greater than or equal to. So if we try to run that again, we'll see that our test still passes. We can also do for the assert greater than, and we can do, okay, we're checking that result is greater than, okay, maybe 20 or something, right? So this is probably not like the best use case for it, right? But I'm just like showing the different macros you have available for like use when you're testing. You could also do stuff like, you can also use the less than. So I want to check that result, maybe it's less than 40, and you also have not equal to. You can also check that this is not equal to. Want to check result is not equal to, let's say 20 or 10 or whatever it is, right? So everything here are valid statements. So if we try to run that, we should be able to like get that to work, right? So the next thing okay, let's just run first. Okay, so as you can see, the test actually passed. So the next thing we're actually going to be looking at, right, is there are cases where, for example, you probably passed in maybe your test do not actually behave as required. So let's say I change this x plus y, right, to maybe x minus y, and this was now subtract two numbers. Now if I run this, you're going to see that our test is going to fail, right, because it no longer behaves as we initially intended. Now in those cases, right, there are probably cases where we could actually have predicted that we wanted this to panic. So this can be used for testing things like, okay, maybe when you're writing smart contracts and you're trying to test access control, you want to make sure you are, as much as you test the positive scenarios, you want to also test the negative scenarios, right? So in those cases, Cairo actually provides you with another attribute called should panic, which you can actually use to like tell the compiler that this, you expect this particular test function to panic. So when you actually do something like that, if the test function does not panic, that's when like the test would actually fail. So we can actually come here and do something like we want, and I just add the should panic attributes. So when we do this, we're just telling the compiler that, okay, I expect this test to fail. So now you see that the test which failed previously will now pass because it was our expectation that the test would pass, would fail, right? So as you can see, this is it. And there are also cases where, like, maybe you didn't expect that the test was going to fail, right? So I'm just going to clear the should panic, right? And maybe you want to pass in extra data to probably explain to maybe someone else or to yourself, right, while this particular test is failing. We can actually do something like that. We can pass in extra, like we can pass in extra data, probably in like byte array format, right, to explain why this test to fail, probably what like the expected result was and all that. So to do that, I can simply come here and do something like I'll say I expected this value, but I got this value. We can do something like that. Now, of course, this is like, we need to fill this in. These are format strings. We need to fill them in. So what we expecting? 20 minus 10 is going to be, because this is now minus, right? So 20 minus 10 is going to be 10. So we'll say we're expecting 10, right? But what did we get? We got we got 30 here. Okay, sorry, we were expecting okay, now in this case, now let's assume we didn't really know how the functions work, so we thought it was addition, right? So let's say we're expecting 30, right? But what we essentially got was 10, something like that, right? So we could actually do that, and when we run that, we're going to see that extra message is probably going to pop up when the test fails. All right. So as you can see, this test fails, and you can see this extra error message, right? That helps you like better understand why the text is failing. So as you can see, we were expecting 30, which we passed in, but what we got right was 10. So these are just very, very simple nuggets you can actually utilize, right, while writing tests. And you can actually even do stuff like, for example, when you're writing, maybe you're writing like a very large test case, probably you use it a lot like in integration testing or something, and you have like multiple test function, and you just want to test like a particular function, right? You do not want to like you look, let's say you want to ignore some test functions. So let's say I'm just going to copy this and paste, right? Just going to copy and paste this. So let's say I have these two test functions. I'm just going to call the sub number function. I have this text function, so I'm going to take this back to I'm going to take this back to plus, so our test to pass. All right, so now I have these two functions, and I want to probably ignore one and test the other, right? I just don't, there's one test I do not want to be part of like my test suite, so I can just do that simply using like the ignore attribute. So I come here and add the ignore attribute, and when I do that and run this, you'll see that test is going to be ignored and just one is going to run. So when I run that, we're going to get so as you can see, our tests, only the test add number function was passed, was run, right? This other one was actually ignored, and you can see one test passed and one was ignored. Also, apart from ignoring tests, you can actually do stuff like run like a particular test function. So let's say I wanted to run just the test sub number function. I didn't want like the add number function to run. I could still do that maybe without even using like the ignore or like the add number function. So I'm probably going to do something like I will just run scarf test, and I will specify like the name of the test I want to call. I want to run, in this case, test sub number function, right? And when I run that, I should have the compiler just or the test runner just running this particular test and ignoring the other. So you can see we have one passed, one test passed and the other filtered out, and the one which ran was like the test sub number function. So these are just like like I said, simple nuggets, the different tools, syntaxes and stuff you can actually utilize when writing tests. One more thing I wanted to also touch on, right, is something you can actually use for cases where you're probably testing a function that runs a loop or runs like a recursive function, something that probably has the chance of like going into an infinite loop, right? You can actually like control the amount of gas your function, your test function can use. So you're essentially saying, I want it to run with this amount of gas, and probably when that gas is finished, the test will like stop executing halfway, something like that. Like basically how it would probably behave in like a reward environment. So you can actually do that using the available gas attribute. So we could actually say we want to use like this available gas, and we can specify a value here, maybe like 2,000, 20,000, 200,000, whatever it is, right? Just specify like the available gas you actually want your test to run with. Otherwise, this available, sorry, not. All right. So you can actually specify like the available gas you want your test to run with. And if, for example, this was a recursive function and maybe it ran into an infinite loop, once it exhausts this amount of gas, it's going to stop running. This can actually also be helpful in like measuring the amount of gas, like your test functions, right? Like how much gas they actually use up like during execution. So these are as much tips and nuggets as I think is actually necessary. So let's dive back into like the Cairo book and see if like we're missing out on anything. All right, so now back into the Cairo book. Okay, sorry, was back here. We already looked at the anatomy of a test function. We've looked at macros. We've looked at all these macros. We looked at custom failure messages. Should panic. Um, we've looked at how to filter tests, single tests, ignoring tests, and using the available gas for like recursive functions and stuff. So something else we'll probably not touch on is like benchmarking Cairo programs. So the profiling feature is like a new feature like that was added to like I think Starknet Foundry, which you can actually use to like analyze and optimize like the performance of your Cairo programs. So I'll urge you to like install the Cairo profiler and go try this out, right? So it's actually like an interesting thing to use. So let's take our quiz and dive into like the next subchapter where we look at test organization. All right. So for our quiz, it says, what is the notation you add to a function to indicate that it's a test? So essentially that's the hash test. All right. Then let's say you have a function with a type this signature and you want to test that F0 should return error. Which of the following is not a valid way to test that? We can already see this won't work because should error is not like it's not a valid attribute. So this automatically is a red flag. All right. So moving into the next answer, it says, does this test pass? All right, so let's look. Division operation, panic zero, division error not allowed, divides, okay, and returns the results. All right, in here we actually testing this function, and we are passing in zero, so we actually expect this to panic, and we're passing it should panic. Now, the errors. So as you can see, these errors are not the same. So the zero division error and the zero division error are not the same. You can see like there are some issues like with the caps and stuff, right? The error has to be the same, or like this test won't pass. So the test would not pass. The answer should be no. All right. So for the final question, what's the output when this test are run with the commands cap, Cairo test, F test? Okay, so this will be ignored. This will not run. This would okay. This will not run because it doesn't start with test underscore. This would run, and this would run. So it should be two passed, one filtered out, and one ignored. So we're looking at two passed, one filtered out, and one ignored. So this is our answer, and so we submit. All right, so as you can see, we got our four answers correctly, and with that, I'll see you in like our next sub chapter. All right, so the next thing we're going to be looking at is essentially test organization. So you writing tests, how what are like the best practices, right, for organizing this test you're writing? So when we started earlier, I talked about how there are two major types of tests you mostly be writing, right? Unit test and integration test. And unit tests are basically like tests you write basically in isolation. So you're testing like components or functions in isolation from like the rest of your code. And the goal is just to confirm that like each function works as expected, right? While with integration tests, you're more or less like testing like how every component within like your smart contract or your Cairo program, right, interacts with each other. Probably like testing against how it interacts also with like basically external resources or factors, right? All those kind of stuff, right? And the basic practice, right, is that most times you do exactly write them together. So your unit test and your integration test does not exactly like go in the same file. So with unit tests, you mostly write unit tests like within the source folder, so the source directory. So essentially, your unit test is going to be contained in the same file as your Cairo program, where your Cairo program exists. And like I said earlier, is you need to append them with the CFG test attributes. And that is how you ensure that the compiler does not compile it when it's compiling, like your smart contract does, reducing like making your compiling or your compilation lightweight, right? And essentially, we've already seen how you write like what's it called, like unit test. So you create a new module, append it with like the CFG test attributes. You write functions within it. You can inherit or basically like bring into scope the functions you want to test again using like the use keyword and the super keyword, right? So you use it to reference like the functions you actually want to like test again. The functions you want to write test, you append them with like the test attributes. That's how you specify to the compiler, right? Okay, I want this is actually a test function. I want the test runner to run this. And something else I didn't mention, right, is you can actually test private functions in Cairo. So of course, like a lot of persons have like different attitude towards testing private functions. Some people feel like it's not really necessary, others feel like it's something that should be done, right? Anyway, if it's something you need to do, you can actually do it. And the difference is not it's not very the approach is not really very different from what we've been exposed to thus far. So you just have to like what's it called, use the use keyword to like basically inherit it or expose it or bring it into scope like within like your test module, and you can test it just the way you write unit tests for like other functions. All right, so now integration tests are actually like the thing I wanted to talk about next. Now integration tests are very interesting, and they're essentially super important, right? Because while you test each of your functions in isolation, you don't know how your program might behave when like different parts or different components begin to interact with each other. Now this is where integration test comes in. So the idea is all the parts of this of our library of our program that we've built separately and in isolation. Now let's test to see how they behave when like they come together, right? And essentially that's what integration test looks like. So let's hop into our like our VS Code editor and just like look at how that is supposed to look like. All right, so you'll notice when we set up like this particular when we set up this the SCAP projects, right? The SCAP workspace for this particular tutorial, we didn't use like the normal Cairo test. We had to go with like the Starknet Foundry test runner, and you can see it has like a different structure. So was always the sources where like your smart contracts and probably your unit tests go into, right? The tests actually, this test folder is where you put in your integration test. So when we created our program initially, right, we saw like some tests functions that were really in there. Now we can't exactly to write like a proper integration test. Now we'll probably have to like write a full-blown Cairo program and probably write the test, right? But in a sense, like I said, there's really no much difference. It's still the same thing, except you don't need like the CFU test attribute, since like it's not within like the source directory, so it's not really going to be compiled by the compiler. Well, all you just need to do is you need to import this R2 number. So let's say I wanted to like, okay, let's try that. So let's say I want to write an integration test for like the function we have, and I'm just going to test. So let's call this test addition, and there's Cairo, right? And you wanted to write test for this, right? So you they basically want to bring this function that you are testing right into scope, the add to numbers. And the way you can do it right is you call use, then you have to make reference to, like, remember, we have to, like, since they do not exist in the same scope, we have to like start from way down from like create, right, to call them. So we need to check like our package name, which is like the testing. So we're going to go all the way from there, from testing. We're going to go into like what is, so from testing we probably just want to go into, is it all right, so BC12, so sleep.cairo. So I think from testing we can actually have access to like our, we already have access to our league.cairo. So we just need like to um call the art to numbers. I believe that will like give us access to like the art to numbers, if I'm not wrong. And you can just simply write test, right? You can just write your test. So I'm just going to copy and paste what we already have just because of time. So I'm just going to copy and paste this, and yeah, so copy and paste this, move this back. And essentially, as you can see, we imported this. So now we do not use the super keyword since they do not really exist in the same file. And so in those, to bring like the add two numbers function we are testing against into scope, we have to like use like a full path, right, to refer to it. Then basically we append our test functions with the test, and write the test functions like below, right? So when writing integration tests, for example, you might want to do certain things, like maybe like set up some basic things, and you can maybe say, okay, I want to have like a setup function, and this is really not going to, you don't want this to be run by to be to, for the test runner to run this, right? But this is supposed to like set up a few things within like that your test add number function is going to use, right? You can actually just do that. So I'll just do something that doesn't really make much sense, but let's say maybe I'm going to get my two numbers here. Let x equals 30 and let y equals 10, right? I'm just going to get both in here, probably just return them as tuples. I'm just going to return x and y. Now that's going to throw an error, so I'm just quickly going to add that here. So they are both going to be unit 16. So I'm just going to return a tuple of unit 16, and I'm just going to add an extra semicolon here, so just so that error goes out. Then I'll probably want to update this to match what we have here, so like it fits with our existing test. So I'm just going to change it to 20, so we have 2010. All right, now we're going to come in here. Now this is a function, right, that helps our test. Think of it as a helper for our test, right? But it's not really a test. That's why we don't need to append it if you like the test attributes, right? So we're going to come here and I'm going to say let x, y. I want let x, y, right, be equal to setup. So I'm just going to call the setup function, right? And I'm just going to come in here and I'm going to pass in here. I'm going to pass in x, and in here I'm going to pass in y. All right. So with that, we should have our test function good to go. And also one more thing I forgot to mention, right? Make sure that like the function you're trying to inherit, right, make sure like it's public. If it's not public, you're going to like the compiler is going to throw errors. All right. So now with all this done, we're going to now try to run. So I'm going to clear here and I'm going to try to run our test. So we're going to go again and run scarf test. All right, so let's see what happens. And all right, so it's taking me a bit. All right, so as you can see, we have three tests passed. Two tests was from like so they were unit tests, and this one was like an integration test. So this is like a very like brief intro to like integration testing, right? There are quite a lot you can actually do. Something else that I actually do, which I believe can actually help you like improve your testing, right, is checking out like other people's test suits and try to like learn from what they've done. Probably learn some good practices and just try to get better from there. One code base I could actually recommend, right, is one which we've been working on at Horse Lab. So I'm just going to go back to like I'm going to okay, give me a minute to trying to go back into my browser. All right, so yeah, back into the browser. Yeah, so this is like this is one of the products we've been working at Horus Lab. So you could check out like the test, and it pretty much like you would find like a lot of like integration tests that could guide you through how you could write proper integration test. So just as you can see, you have like a setup function which helps like do a few things like deploying the contracts you want to test and other things, right? And you can see how like you write all that test, how you can check against like different things, how you can, for people who have posted writing smart contracts, right, how you can use like some of like the cheats available to you from like Starknet Foundry, which you can basically like utilize to like mock some environmental variables, right, on like the Starknet environment. So I think that's as much as we are going to cover for today. Let me see. So we already looked at integration testing. All right. So some modules in integration testing, you can probably just look at that later. And yeah, I think that's as much as we need to cover for testing. So one thing before I go, right, is thus far we've like covered everything you need to know about like the Cairo programming language in itself. Now, the next thing we're actually supposed to go into, right, is building Starknet smart contracts. So think about it as how you probably like learn a language like JavaScript, and then you use like a framework like Next.js to build like better web applications, right? So essentially everything you've learned in those 12 previous episodes, in these 12 episodes, right, are what you're going to use to like build Starknet smart contracts. So the changes are like just a very few things here and there, and trust me, you're good to go to actually like start building proper like Starknet smart contracts. And for those who are going to like be who are interested in like going ahead of us, because this is going to be the last episode in this particular series, hopefully we're going to create a different series or a different video, right, totally targeted at like Starknet smart contracts. But if you're looking to go ahead, one of the tools I will actually recommend for like smart contract development, right, is a tool we built at Horus Labs. So it's called Starknet Scaffold. So let me see the GitHub repo. So you can actually like check it out. Starknet Scaffold. So Starknet Scaffold is basically like an open source up-to-date toolkit you can actually use to like build decentralized apps on Starknet. So it provides everything you probably need from like scripts. Think of like like ready to use scripts, right? So when you probably start tinkering with Starknet Foundry and the rest, it might be like a bit difficult to like know how to use most of these scripts. We have scripts to help you with that for like normal smart contract development. For those that are going to be building Dojo games, right? We also support Dojo. You can actually like build stuffs and deploy stuffs using Starknet Scaffold on Dojo. And we have like this beautiful UI you can actually use, like there are existing UI components you can actually utilize from there. All right, so you can actually find that Starknet Scaffold, yes, scaffold.xyz. All right, so yeah, basically everything you need to build apps on Starknet, and all you just need to do, right, is you can start with this simple command npm create Starknet app, and that's as much as you need to just get started building. So I would encourage you to actually check it out. It's a very helpful tool. And like I said, there are a lot of existing UI components you could use. There are things that are very helpful. For example, for deployment, you need like a burner wallet. You can easily just connect your wallet and deploy one and use that for testing purposes on Sepulia. You can add tokens to like so there's this UI component called add token. You could actually use like add tokens to like your probably like Sepulia wallet. There's the network switcher which you could actually use in your dApps too. There's the Wikipedia section which shows you like everything, a lot of important things, right, you need to know about like the Starknet Cairo ecosystem, the tutorials, plugins, blogs, official website, documentation, SDKs, and the community in general. You would find all those things on like on the Wikipedia. There's a stack converter which was not built by us, but we added it because it's like an important tool you can actually utilize for like when you start building contracts for converting from like field 252 to hexes to strings and so on and so forth. There's the deployer we have which you can actually use to like deploy stuff right from like the browser. So you want to deploy your smart contract on Starknet and you don't want to like tinker or play around with Foundry and the rest, you can do that right from like this interface. Just just upload your Sierra and Chasm files, and we're going to like handle the deployment for you, and plenty other things he actually like offers you for like Starknet development. So I would encourage you to actually check it out. And with that, we've come to like the end of this particular series. I want to say a very big thank you for like sticking to like the end, and I'm sure at this point you have like, trust me, you have like all it takes to actually start building like amazing stuffs like on Starknet, building provable programs and plenty other things, right? Because the beauty of Cairo is not limited to Starknet. You can use it to like do a whole lot more beyond just beyond Starknet, right? But like I said, if your goal is to actually become like a Starknet smart contract developer with everything you've learned thus far, I wanted to actually move on with that to actually start learning. Like you can actually also use the career book for now to like learn everything you need to know about like building smart contracts on Starknet. And once again, thank you so much for sticking on to the end. And if you've not done it, I would say it once again, do like, subscribe, hit the notification bell, so whenever we begin a new series again, you are actually informed. And I would probably like to like get your review on how the series was. If you enjoyed it, there are things you probably want us to do better in the next series, please reach out to me on Twitter at ZerexDarlington, or on Telegram at Darlington68. And I would see you in the next one. Take care. Bye.